Right, the first 6 of 11 questions on dealing with the integral of rational functions other than partial fraction types, where you have a quadratic which needs to be either identified immediately as a logarithm or rearranged into the form of 1 plus or minus the square of a linear function by completing the square to identify an inverse sine or tan. So with these integration ones, the first one, quadratic's in the denominator. So first thing to check is if it factorises. So we've got 4 taken away 4 is 0. It does factorise. In fact, the 0 means it's going to be a perfect square. That's even better. So that's just going to be x plus 1 squared. No need for partial fractions there, because that's just like 1 over x squared. So the answer would just be power negative 2. We'll go back to power negative 1. So it'll just be x plus 1 divided by that negative power. So that's negative that. Plus c. That one was easy. 3.36 integral of 2x plus 2 over x squared plus 2x plus 1 dx. Well, it's the same denominator, but I'm not going to factorise that because the first thing I notice straight away is the top's the derivative of the bottom. Differentiate the bottom, 2x plus 2, I've got 2x plus 2. Now, as soon as you got that, you don't need to do substitutions when it's as blatant as this. If I've got the integral of f dashed x over f of x dx, then I know straight away the integral is going to be the logarithm of f of x, okay, plus c. Because when you differentiate that, it's going to be 1 over the function multiplied by the derivative of the function. More so, if I had the integral of some multiple of the derivative on top over the function itself underneath dx, I know that the answer is going to be that multiple of the logarithm of the function underneath. These you can do by inspection. So I can answer this by inspection straight away. That is precisely the derivative of that. So the integral of that is just log n x squared plus 2x plus 1 plus c. And if I wanted, I could go further. I could say that's ln of x plus 1 squared plus c. Or even 2 times ln x plus 1 plus c if I wanted. But the point is, you can integrate that by inspection. Right, next one. 3.37. 3.37 looks like this. I've got x squared plus 4x plus 8 over that same denominator. I want the integral of that. Well, this time the top is of the same degree as the bottom, so you could divide it in, but you don't need to carry out a big long division at the side to do that. I can split that up quite easily. Because all I want to have is, I could just separate the top to fabricate the same expression as the bottom. So I could just write x squared plus 2x plus 1 over x squared plus 2x plus 1. And then see what's left over, and that can make the next part, x squared plus 2x plus 1. Well, I've used up 2 of the x's, there's 2 left over. I've used up 1 of the constants, so there's another 7 left over. And then I think, oh wait a minute, this part that I've got here, that's close to the derivative of the bottom. So I can break this up one more time. So I've got x squared plus 2x plus 1 over that. I could have cancelled that down straight away. I'll take out the derivative of the bottom, leaving x squared plus 2x plus 1, and I've still got 5 left over. 5 over x squared plus 2x plus 1 dx. What this is showing in here. So for the last part it would be, well, what have I got? I may have to move this up a bit. So that just comes to 1. Well, I could just go straight back to that. I could just integrate it straight away. That comes to 1, so that'll just go back up to x. That's precisely the derivative of the bottom, so by inspection, that's going to be ln of x squared plus 2x plus 1. And that I had already was x plus 1 squared, so that'll just be minus 5 over x plus 1, the same way as with the first one, plus c. Splitting it all up. Right, pause. Right, board cleared. 338 now. Right, for this one. Now, the point about this one is that's quite close to the derivative of the bottom. If only that had been a 2x But then it would do as a single x, because then it would just be a multiple of it, it'd be a half of it. So I don't need all of that too. I could demonstrate that by saying I've got a half of what I need, and what I needed was 2x plus 2 over the x squared plus 2x plus 2, and then correct it in the second part. So a half of that means I've got the x, I've used it all, and I've got 1, so there's still 1 left over. 1 over x squared plus 2x plus 2 dx. Maybe I'll just reduce this first part straight away. So that means I've got a half of, by inspection, the log of x squared plus 2x plus 2. And then I've got to decide, what do I do with this part here? Well, that wasn't the same as the first one with a 1 in it. This one's got a, I should have said, the discriminant of this is going to be negative, so it won't factorise. So what I'll do instead is I'll complete the square. So if I've got x squared plus 2x plus 2, if that's showing there, the sun's coming back out again, I can rewrite that as x plus 1 squared. Leave the 2 at the side. That would have introduced a 1, so I'll have to take away a 1 from this, so minus a 1. So what I've got is 1 plus that, 1 plus x plus 1 squared, and that's perfect. So plus the integral of 1 over 1 plus x plus 1 squared dx. And then that's recognised, you can recognise it instantly as an inverse tan. So the final answer would be a half ln x squared plus 2x plus 2 plus inverse tan x plus 1. The derivative of that's 1, divided by 1, makes no difference, plus c. Right, clear the board for the next one. 3.39. Now, this one's going to be a bit messier. Well, the first part is, that looks as if it's heading towards an inverse sine, but I'll have to tidy at the bottom. That'll need to complete that square. So the first step would be, I'll just write that the other way around. Negative x squared plus 4x plus 5. Take out the negative. X squared minus 4x. Leave the 5 out of it just now. And then that would be x minus 2 all squared. But then that would create a plus 4. So I'll have to do minus a 4 plus the 5. So then altogether what I've got is I've got negative x minus 2 squared plus 4 plus 5 is 9. So it's 9 minus x minus 2 squared, which you could use the way it is if you can remember the formulas. When is it 1 over a, when is it not 1 over a? We'll just take it one step further. Take the 9 right out of it to have it in the form 1 minus the square, which means that would be x minus 2 squared over 9, or putting it into the bracket 1 minus, and then just to get it as a thing squared, 9 is 3 squared. That would do. So I could change that. So I've got the integral of 2 over 9, the square root of, 9 times 1 minus x minus 2 upon 3 all squared dx. Now I'll just take those constants out of it just now, so that I've got that 2 on top. That 9 can come out of the square root as a 3, so I've got 2/3 of the integral of 1 over, nice and clear now, 1 minus x minus 2 upon 3 squared dx. And that's just an inverse sine. So I've got 2/3 inverse sine x minus 2 upon 3, but divide by the derivative of that inner function. Its derivative is a third, so divide by a third, that'll end up multiplying by 3, and then don't forget the plus c. So the final answer, 2 inverse sine x minus 2 upon 3 plus c. 3.40. These are getting harder now, I think, a wee bitty. 2x plus 3 over 4x squared plus 4x plus 10 dx. Right, what can we do with this? Well, the first step is there's a pile of 2's at the bottom there, and take that out. So take 2 out from the denominator. That's in the denominator though, so it'll be a half of 2x plus 3. I was just about to take you out as well. 2x squared plus 2x plus 5 dx. Right, the next part would be this. Right, that's pretty close to the derivative of that. if I had 4x plus 2, it would work. Well, I've got half of that, so I've got half of what I want. I actually want 4x plus 2 to match this, to be its derivative. That means I'll have a bit left over here as well. So half of that is, I'm using up 2x, that's all of that gone, and 1, so there's another 2 left over. So 2 over 2x squared plus 2x plus 5. So now it's come down to this. Now, what about the derivative of this? Same again, 4 minus 40, negative discriminant, that's not going to factorise, which means I'm going to complete the square here. If it factorised, I'd have tried partial fractions, so I've got to muck about with that. Where have I got room to do this? Can I do it up here? So take out the factor of 2, leaving me x squared plus x, forget the 5 just now. That would be as a square plus half of that plus a half. That would introduce an extra quarter, so I'll have to remove that quarter plus 5. So I've got 2 times x plus a half minus a half plus 4 and a half squared, and 4 and a half is plus 9 upon 2. So I've got 9 upon 2 plus that. Same again, I could take that 9 upon 2 out and leave it as plus. And if I take 9 upon 2 out of an expression, everything that remains will have to get multiplied by 2/9. So 2/9 times this would make it 4/9 of x plus a half squared. And then finally just tidy that up, because I want that inside the square. Well, 4 goes inside the square as a 2, and a 9 goes inside the square as a 3, because that's 3 squared. So I've got, where did that one go? So I've got 2 in type, that's actually very handy, that makes 2x plus 1. So 2x plus 1. And then the 9 goes in as a 3 upon 3 squared. So this is going to become a half of, now I could have resolved this just now, half of 4x plus 2 all over 2x squared plus 2x plus 5 plus, and this is going to become 2 over 9 upon 2 times 1 plus 2x plus 1 upon 3 squared dx. And then I can see the two patterns. There's a logarithm, because I've got the derivative of the denominator, and there's an inverse tan. So don't forget that half at the front. So that's a multiple of the derivative of the bottom. So that's a half of log n, and I've got a half again. So that's going to be 1/4 of log n of 2x squared plus 2x plus 5. In this part, again, I've got a half of this. Well, half of the 2 is nice and easy, because that's going to cancel out. I've got 1 over 9 upon 2, so that'll be plus 2/9 of the inverse tan of 2x plus 1 over 3. That's inner function, that linear inner function has got a derivative of 2/3, so I'll need to divide by 2/3. That's the same as multiplying by 3 upon 2. So finally I've got 1/4 of ln 2x squared plus 2x plus 5. They'll cancel out, that'll take it down to 1/3, plus 1/3 inverse tan of 2x plus 1 over 3 plus c. I'm using my red pen now this time. There, that'll do for now.